We've all been there, right? You're on a web app, you click a button, you start typing in a search bar, and nothing. The whole page just locks up. It is so frustrating. Well, today we're going to pull back the curtain, figure out exactly why that happens, and more importantly, how to fix it. Let's get into it. So here's our game plan. First, we'll talk about that universal feeling of a frozen app. Then we'll meet the culprit, the main thread. After that, we'll jump into some really smart strategies and optimizations, see them in action with a real-world case study, and wrap it all up with a checklist you can use on your own projects. All right, let's start with the problem itself. That moment of absolute helplessness when a UI just stops responding to you. It's an experience that can make even the most amazing application feel completely broken. I mean, seriously. You click, you wait, you click again. Maybe you start hammering that mouse, wondering if it's your computer or the app itself. That lag, that unresponsiveness, that is the #1 enemy of a good user experience, and it's exactly what we're here to defeat.
So, who's actually responsible for this digital gridlock? Well, it all comes down to one single, incredibly busy entity. It's time to meet the hardest and, frankly, the most overworked part of your browser, the main thread.
Okay, think of the main thread as the head chef in a one-person kitchen. It has to take orders from the user, run your JavaScript, that's like cooking the food, calculate all the styles and layout, set the table, and then finally serve the meal by painting pixels to the screen. It does everything. And just like a chef trying to do it all at once, if one task is too big or takes too long, the whole restaurant just grinds to a halt.
Now, here's where it gets really interesting. All these jobs are completely tangled together. The main thread is constantly cycling through these 4 things. Running your JavaScript might change its style, which then forces a layout recalculation, which then requires the browser to repaint the screen. It's a total domino effect. If any one of these steps takes too long, everything else gets stuck waiting in line, and that's when your user is just staring at a frozen interface. Okay, so we've established the main thread is totally overworked. The solution isn't to just throw more code at it. Nope, the solution is to be smarter about the work we give it. This next section is all about the strategies we can use to give our poor main thread some much-needed breathing room. Let's start with those events that fire like crazy, like typing or scrolling. Instead of running a function on every single keystroke, we can use debounce. This is perfect for a search bar. It just waits until you've paused typing for a split second to go fetch the results. Throtter, on the other hand, is amazing for stuff like scroll tracking. It makes sure your function runs, say, every 100 milliseconds, but no more often than that. So debounce is like waiting for a quiet moment to speak, while throttle is like speaking at a steady, controlled rhythm.
But what about those really heavy-duty tasks, like parsing a huge file or doing some complex data filtering? For that, we can basically hire an assistant chef. A web worker runs your JavaScript on a completely separate background thread. This is a total game changer. You can offload all that heavy lifting to the worker, and the main thread is totally free to keep the UI feeling smooth and responsive. Now here is a classic performance trap. It's called layout thrashing, and it's nasty. Imagine you're building a house. You wouldn't measure a wall, then cut one board, then go back and measure the same wall again, then cut another board. That's crazy. But that's what happens here. If you ask the browser for an element's width right after you've changed its style, you're forcing it to stop everything and do extra work. Do that over and over, and you'll bring your app to its knees. And the solution is beautifully simple: batching. The smart way to do this is to separate your reads from your writes. First, read all the dimensions and positions you need from the page. Get all your measurements. Then, in a totally separate step, make all your style changes. This lets the browser perform all its calculations in one efficient go, instead of getting interrupted over and over again. So we've talked about how to manage the tasks we give the main thread, but that's only half the battle. What about the actual process of drawing stuff on the screen? Optimizing the rendering is another huge piece of this puzzle. It's all about making that painting process as cheap and fast as possible. You have to know this. Not all CSS properties are created equal. Animating things like width or top is really expensive because changing them can affect the position of a bunch of other elements, forcing the browser to recalculate the whole page layout. But properties like transform and opacity are special. The browser can hand these animations directly off to the computer's GPU, the graphics processor, which is built for this stuff. It completely bypasses that expensive layout step. It's like having a dedicated painting assistant that's lightning fast. And there are even more power-ups.
Got a list with thousands of items? Don't render them all. Use virtualization to only draw the handful that are actually on the screen. Don't make the user download code for a feature they might never use. Lazy load it when they click the button. And if a component's data hasn't changed, memoize it. Memoization is just like taking a snapshot and reusing it. It's a super powerful way to avoid useless work.
All right, enough theory. Let's see how all of these techniques come together to rescue a real-world app from a performance disaster. This is the fun part, where we take our new toolkit and apply it to a slow, frustrating dashboard and see what happens.
Okay, so here's our patient. A dashboard with a massive 10,000-row table, some really slow filtering logic, and a bunch of charts. The symptoms? Typing in the search bar felt like you were typing in slow motion, and the first time you loaded the page, it took forever. It was basically unusable. So here's how we tackled it piece by piece. For that slow typing, bam, we dropped in a 200 millisecond debounce. That heavy filtering logic, we kicked it off the main thread entirely with a web worker. That giant 10,000-row table, tamed with virtualization. And that slow initial load, fixed by splitting up the code and lazy loading the pieces. And the results? Oh, the results were good. Let's start with the typing lag. The time between hitting a key and seeing the character on screen went from a painful 400 milliseconds all the way down to just 20. That is a 95% reduction. That's the difference between an app that feels broken and one that feels instantaneous. And what about that initial load time? We chopped it down from 3.2 seconds to just 1.1 seconds. That is a massive improvement in a user's first impression. This dashboard went from a total performance nightmare to a smooth, responsive tool that people actually wanted to use. So, we've seen the problems, we've learned the strategies, and we have witnessed the results. Now let's just boil all of this down into a simple, actionable checklist that you can take and apply to your own work. Here it is. This is your cheat sheet for taming the main thread. Offload the heavy stuff, manage your events, virtualize those long lists, animate with the right properties, batch your DOM reads and writes, stop useless re-renders, and be smart about your code delivery. I promise following these principles will make a world of difference. And that really brings us to the end. The main takeaway here is that web performance isn't some kind of dark magic. It's just a series of deliberate, smart choices. So the final question I'm going to leave you with is this. Thinking about the apps that you work on, what's the first bottleneck that you're going to go out and fix? Thanks for watching.